When you picture gold mining, you probably imagine someone plucking a shiny, solid nugget out of a riverbed. But modern industrial extraction looks completely different. Today, it is an exercise in hunting down microscopic specks hidden inside literal mountains of solid rock. To even reach those specks, facilities first crush millions of tons of raw ore into a chaotic, muddy slurry. This violent mechanical step separates the valuable minerals from the useless surrounding waste rock, which miners call gangue. But that creates an immediate physical problem. Both the microscopic gold and the crushed rock are incredibly dense materials. If you dump them into a vat of water, gravity takes over and they both naturally sink straight to the bottom. Looking at a modern processing plant scale, how do facilities separate invisible gold flecks from millions of tons of mud without manual sorting? The solution forces engineers to abandon mechanical force. Instead, they rely on chemical manipulation, specifically finding a way to effectively defy gravity and make the heavy gold float. The separation happens here, inside massive churned flotation tanks filled to the brim with that raw slurry. The first chemical phase requires flotation conditioners. Operators introduce industrial chemicals like sulfuric acid or lime into the tanks to precisely tune the pH level. Once the water is prepped, they introduce a second set of compounds called flotation collectors. Depending on the exact nature of the ore, they might use xanthates for sulfide-heavy rocks or fatty acids for oxidized ores. These collector molecules selectively bind to the surface of the gold particles, ignoring the surrounding gray waste rock. This triggers a crucial physical reaction. The gold surface becomes intensely hydrophobic, suddenly repelling water. Meanwhile, the gangue remains hydrophilic, absorbing the liquid. This invisible molecular toggle switch drives the entire operation. Without forcing the gold to chemically fear the water, the physical lift cannot happen. So now, the gold desperately wants to escape the water, but it still weighs exactly the same. It needs a physical transport vehicle to carry its dense mass all the way to the surface. That introduces Phase 3, foaming agents. Operators add specific compounds, like eucalyptus or camphor oil, while mechanical agitators violently churn the tanks. This intense mixing injects millions of tiny, resilient air bubbles straight into the muddy, churned mixture, forcing them to rise. Because the gold flecks are now highly water-fearing, they latch on to the passing air bubbles to escape the liquid, hitching a ride upward. The water-loving gangue ignores the bubbles entirely and continues sinking. By combining a precise injection of air with induced chemical fear, the engineers effectively reverse gravity, forcing the heaviest element in the tank straight up. At the top of the tank, a thick metallic froth forms. This layer, known as the concentrate, successfully suspends all the valuable extracted gold. Down at the bottom, you find the sunken, useless dirt and waste rock. In mining terms, these are the tailings. Operators simply skim the gold concentrate right off the top of the bubbles, achieving perfect separation of microscopic particles on a massive industrial scale. This physical chemistry is highly elegant compared to alternative extraction methods like heap leaching or CIP processes. Instead of floating the metal, those methods use chemical solvents to fully dissolve the gold out of the rock. Historically, those dissolving methods have relied on heavily concentrated, highly toxic cyanides. The massive environmental footprint and pollution risks of cyanide extraction led to it being outright banned in many countries in favor of eco-friendly alternatives. Modern mining succeeds by leveraging the physics of surface tension. By coating microscopic gold in a layer of chemical repulsion, plants force the densest particles in the slurry to simply float away.